Hey guys, today we're going to be investigating how to use molar mass to help us predict other quantities. So, first of all, don't forget to write down the DRQ for today in your notebook. It's posted on the Google Classroom assignment. And I'm going to try to use my whiteboard here and this little setup I've got going on to try to do some math for you guys today. So you'll need a calculator, something to write with. You can use your notebook to take down the same notes that I am giving to you right now. So today's class is it's a little bit of a review of something I think that you should remember from math class. In math class, you probably learned about something called a proportion. Now, a proportion is basically a relationship between two quantities. So a really simple proportion for us, something we're all familiar with, is that 12 eggs equal 1 dozen. Now, I specifically chose the word dozen because for us, in chemistry, we don't use dozens as our counting unit like we would buy eggs at the grocery store. But remember, we use a counting unit called the mole. And the mole also equals a specific amount of items, just like a dozen equals 12. So we'll start with dozens because that's what we're familiar with, and then we'll start to transition into how this is important to chemistry. So proportions can be used to answer all kinds of questions, but you need to know a relationship to help you first. Imagine that I told you that 1 dozen eggs weighs about 600 grams. And now we can think about, well, what can we do with that information? Well, there's a lot of questions that we could answer. For example, we could ask ourselves, well, how heavy would 3 dozen eggs be? In other words, what is the mass of 3 dozen eggs, or how many grams are 3 dozen eggs? To answer that question, we have to use something called a proportion. So some of you might be able to figure this out in your head. You're like, oh, well, if 1 dozen is 600 grams, then 3 dozen is, and you can do the math. But what you're really doing is something called a proportion. You're assuming that if 1 dozen is equal to 600 grams, then that means that 3 dozen eggs would be equal to an unknown amount of grams. And to solve for this, all you would do is solve for x. So you cross multiply. So you'd get x equals 3 times 600. X equals 1,800 grams. Now again, some of you were probably really quick to figure that out because you were able to use the proportion. It gets a little bit more challenging when we use numbers that aren't so easy to look at. You know, the number 1,800 or 600 or 3, those are easy values. But in chemistry, we don't get a whole lot of easy values. So let's try a more difficult one. What if I told you that I had 267 grams of eggs? And I wanted to know how many dozens that was. How would you figure that out? It's not as easy to figure out in your head anymore, so you definitely need to use the proportion. We still know that 1 dozen is equal to 600 grams. But now we want to know how many dozens are equal to 267 grams. But the math is still the same. We just cross multiply and solve for x. Just takes a little longer to solve for x this time. Cross multiply, you have 600x equals 267. And then for us to solve for x, we can just divide both sides by 600. And we find that x is equal to 0.45 dozens. So now we know that 0.45 dozen eggs, or just about half a dozen eggs, weighs 267 grams. Now, this doesn't sound that useful, but trust me, it is. Let's try another one as an example. Let's just get rid of all this. keep our relationships, because those are important. So here's another question. Well, what if I had 1,600 grams? How many dozens would that be? So again, we need to use our proportion. We know that 1 dozen equals 600 grams. And now I want to know how many dozens is 1,600 grams. Again, we cross multiply, we solve for x, we cross multiply, we have 600x equals 1,600 grams. Divide both sides by 600 in order to solve for x, and we would find that x is equal to 2.67 dozens. So somewhere between 2 and 3 dozen eggs weighs about 1,600 grams. Now, what does this all have to do with chemistry? So in chemistry, remember, we don't count by hand. You can technically go to the grocery store and, pick out 3 eggs, I guess, if you wanted to, but we don't have that luxury in chemistry. The only way that we can count in chemistry is by weighing. Everything we do in the laboratory is grams. Even though we use the quantity of the mole, it's not like we can go into the lab area and start weighing out samples in moles on a balance. We have to weigh out samples in grams on a balance and then turn them into moles to use in the laboratory. And so our math skills have to be pretty good. Our proportions have to be pretty good so that we can get it right. So let's transition now into chemistry and see if we can make that work. When we look at a chemical reaction, something like 2 molecules of H2 plus 1 molecule of O2 yields 2 molecules of H2O, what we're really saying is that 2 moles of hydrogen react with 1 mole of oxygen to yield 2 moles of water. But if we want to be able to use information like that, we need to be able to go into the laboratory and weigh things out. And again, we can't do so in grams. We have to do it in moles. So we have to use the molar mass in order to figure out information in terms of chemistry. And to use molar mass, we have to turn it into a proportion. So it's really important that we realize what molar mass really is. Remember, molar mass tells us the mass of 1 mole. So if we're looking at a chemical compound like water or H2O, we're saying, well, how heavy is 1 mole of water? And if we practice what we learned last class, which is to calculate molar mass of a compound, we'd say 2 hydrogen plus 1 oxygen gives us a molar mass of 18.02 grams in every 1 mole. And what we find out then is molar mass is really important because it gives us that relationship or that proportion that we need in order to calculate other pieces of information about water. So, for example, if the molar mass of water is 18.02 grams in every 1 mole, that's our molar mass for water, then we can answer questions like, how many grams are in 3 moles of water? So if I wanted to know what is the mass of 3 moles of water, we could use that prediction or that proportion to help us predict how heavy 3 moles of water would be. So we could say, all right, well, I know that every 18.02 grams is 1 mole. So how many grams are there in 3 moles? And again, we just have to cross multiply and solve for x. And when you do so in this case, you would find that you would get 18.02 grams times 3 equals X. And you would find out that X is equal to somewhere close to 60 grams of water or so. Okay? We can make these even more complicated because, again, when the numbers are easy, it's easy to do these. But when the numbers get more complicated, it becomes a little bit more challenging. So again, what if I had 267 grams of water? How many moles is that? So we would again have to set up our proportions. So again, 18.02 grams is equal to 1 mole. So how many moles would I have if I had 267 grams? Cross multiply and solve for X. We'd have to say, okay, well, 18.02 X equals 267 grams. We don't need to keep that with us. Divide both sides by 18.02. Solve for X. And you would find that X equals 14.81 moles of H2O. Okay? Let's try another one. Just to practice. Imagine if we had 1,600 grams of water. How many moles would that be? And again, same proportion because this proportion tells us how many grams there are in every 1 mole. So what if I had 1,600 grams? How many would that be? So again, we say, all right, well, I know that I have 18.02 grams in every 1 mole of water. So how many moles would I have if I had 1,600 grams of water? Cross multiply and solve for X, and you would get 1,600 equals 18.02X. Divide both sides by 18.02 to get the X by itself. And we'd find out that X equals 88.79 moles of water. And that's about how many moles there are in about 1.5 liters of water. Okay? So as long as you know the molar mass and can set up these proportions, you should really easily be able to calculate the number of moles in any gram sample of a substance. Okay? So I gave you guys a handout for practice. So on Google Classroom, you guys will see a couple attachments today. You probably see this video. You'll see your DRQ, and then you'll see some practice problems for you to work on. So you can work on those in your notebook and then take a picture of them and go ahead and upload them to Classroom so then I can see that you got them done. This stuff can be pretty challenging. So if you are stuck at all, please reach out via Google Classroom or Hangouts or email, and we can set up a time to kind of go over a couple more examples, maybe like this if you need to. And so just let me know. I miss you guys. I hope to see you soon. Bye.